Hello everyone. I welcome you all for the course on engineering mechanics. Before discussing the course engineering mechanics, let's discuss about the course mechanics. Mechanics is a very interesting, fascinating and so important subject for a mechanical engineer. In fact, if you know the mechanics, you are almost an engineer. Mechanics is not a single course. It is a sequence of few courses. They are statics, dynamics, kinematics of machines, dynamics of machines, mechanics of materials, design of machine elements, design of transmission systems, and fluid mechanics. Out of these 8 courses, except fluid mechanics, in all the courses, the concepts of mechanics is applied on solids. In fluid mechanics, the concepts of mechanics are applied on liquids and gases. This liquid and gases commonly known as fluid. When statics and dynamics combined, they are called engineering mechanics or rigid body mechanics. Similarly, when kinematics of machines and dynamics machines are combined, they are called theory of machines or mechanics of machines, and mechanics of materials, also known as deformable bodies mechanics. In this semester, we will discuss statics, part of the engineering mechanics. The dynamics part of the engineering mechanics will be discussed in the second semester. The kinematics of machines, dynamics of machines, mechanics of materials will be discussed during your second year course. Design of machine elements, design of transmission system will be discussed during your third year course. Fluid mechanics will be discussed during your fourth semester and fifth semester course. In summary, this mechanics is a branch of physical sciences that is concerned with the state of rest or motion of bodies that are subjected to the action of forces. In general, this mechanics can be subdivided into 3 branches: rigid body mechanics, deformable body mechanics, and fluid mechanics. During the first year, we will study rigid body mechanics. Since it is a basic requirement for the study of mechanics of deformable bodies and mechanics of fluids. Furthermore, rigid body mechanics is essential for the design and analysis of many types of structural and mechanical components. Now, let's start our discussion about the course engineering mechanics. Engineering mechanics is the science which deals the effect of forces on object either at rest or in motion. The engineering mechanics is classified into 2 categories: statics and dynamics. Statics deals the bodies at rest and dynamics deals the bodies in motion. Dynamics further divided into 2 categories: kinematics and kinetics. Kinematics is the branch of dynamics in which the force which caused the motion are not considered. Our main focus is the displacement, velocity, acceleration and time. Kinetics is the branch of dynamics which consider the forces which cause the motion. So, this statics deals with the equilibrium of bodies and dynamics is concerned with the accelerated motion of bodies. We can consider statics as a special case of dynamics in which acceleration is 0. However, static deserves a separate treatment in engineering education since many objects are designed with the intention that they remain in equilibrium. Rigid body. Rigid body is a body which does not deform under the action of forces. A rigid body can be considered as a combination of a large number of particles in which all the particles remain at a fixed distance from one another both before and after applying a load. This rigid body differs from an elastic body in the sense that the latter undergoes deformation under the effect of forces acting on it and returns to its original shape and size on removal of the forces acting on the body. In real sense, no solid body is perfectly rigid because every body changes its size and shape under the effect of forces acting on it. In actual practice, the deformation, that is, change in shape and size of a body, is very small and therefore it may be considered as a rigid body. Particle. Particle may be defined as an object whose mass is concentrated at a point, which means a particle has a mass but a size that can be neglected. For example, the size of the Earth is insignificant compared to the size of its orbit, and therefore the Earth can be modeled as a particle when studying its orbital motion. When a body is idealized as a particle, the principles of mechanics reduced to a simplified form since the geometry of the body will not be involved in the analysis of the problem. Statics. Statics is the part of mechanics which deals with the bodies at rest. Dynamics is the part of mechanics which deals with the bodies in motion. Kinematics is a branch of dynamics which deals with the body in motion when the forces which cause the motion are not considered. Kinetics is a branch of dynamics which deals with the body in motion when the forces which cause the motion are considered. Thank you.